So, thermochemistry is the study of heat energy transfer during chemical reactions. So, yung reaction medium, guys, and its components, yun yung system. While chemical reactions between the system and the surroundings involve heat transfer. Okay, so for this part of our thermodynamics one, we will discuss the properties of enthalpy, enthalpies of physical changes, enthalpies of chemical changes, and the variation of enthalpy with temperature. Okay, let's G. So, we know that enthalpy is an extensive property. So it depends on the amount of substance presence. By following Hess's law, the following properties of enthalpy enables accurate calculation of heat changes in chemical reactions and physical processes. So first property is that enthalpy, the enthalpies of reactions can be scaled. So for example, here you have a reaction A plus B forms C products, okay? And you have a delta H. You can scale this whole reaction by multiplying it all to 2. Pag minultiply mo to 2, okay? Then dapat multiply mo rin to 2 ang iyong enthalpy change. Next, for reversing the reaction, the sign of the enthalpy of reaction is reversed when the reaction is reversed. So, for example, in this reaction, pag kunwari, ni-reverse mo siya, ito na yung reverse version niya, then you should also reverse the enthalpy change value by putting a negative sign. Lastly, the Hess's law of constant heat summation, it indicates that the standard enthalpy of an overall reaction is the sum of the individual reactions into which the reactions might be subdivided. So basically, yung sum ng individual reactions, for example, ito, and ito, results in the overall reaction ito. And when you combine two equations, guys, syempre, kailangan nyo din i-combine yung respective enthalpy changes nila. Okay? Oh, tingnan natin sa example na ito. When you combine reaction 1 with reaction 2, maka-cancel out ng C D plus E, right? And this results in an overall reaction of A plus B forms C. Tapos, ang value ng delta H nila is the summation of delta H of the first reaction and delta H of the second reaction. Now, let's try to answer. What is the standard enthalpy of formation for glucose? Given glucose plus oxygen forms carbon dioxide and water. So, in this reaction, guys, okay, try natin i-determine ang standard enthalpy of formation using the properties of enthalpy. Here, we are given the enthalpy of combustion for glucose, which is equal to negative 2808 kilojoules per mole. Enthalpy of formation for CO2, which is equal to negative 393.5 kilojoules per mole. And lastly, for the enthalpy of formation for water, that is negative 285.8 kilojoules per mole. So, solving, guys, okay, again, ang hinahanap natin sa sample problem na ito is the standard enthalpy of formation for glucose, which is this one. Okay? Pero ang given sa atin, guys, is the enthalpy of combustion for glucose. Okay? Which is just analogous to the enthalpy of combustion for the reaction. Okay? So, let's analyze. So, basically, the enthalpy of the combustion of glucose, or the enthalpy of combustion for the reaction to occur, is just products, the enthalpy of the products minus the enthalpy of the reactants. So, let's solve. So, for the products, the coefficient is 6 for carbon dioxide. That's why 6 times the enthalpy of formation for carbon dioxide. Plus 6 times, since we have a coefficient 6 here, times the enthalpy of formation for water. Minus the reactant, which is glucose. So 1 times the delta HF, or the enthalpy of formation for glucose. Okay? So again, guys, ang mga known values natin is the delta CH glucose, which is negative 2808, and yung delta FH ni CO2 and ni water. Ang hinahanap natin ay ang enthalpy of formation ni glucose. That's why ito ang X natin. Okay? Ito. So, using our shift solve function, the enthalpy of formation for glucose is equal to negative 1,267 kilojoules per mole. Okay? Ayan, given the overall reaction below, calculate the enthalpy of reaction. So here we have graphite plus 4H2 forms C3H8. And then we have to find the enthalpy of reaction. Again, guys, the enthalpy of reaction is equal to the summation of the enthalpy of the products minus the summation of the enthalpy of the reactants. So guys, tingnan natin na mabuti ito. Okay? Here, we are given individual reactions. So, kunwari wala pa to. Okay? Kunwari wala pa yan. Ito yung mga reactions na given. Tapos, kailangan natin mahanap yung overall reaction, which is dapat ito. Okay? So, ang goal natin, guys, is to obtain this overall reaction. O, paano? We have to scale each of these individual reactions. So, for reaction 1, ang gagawin ko ay i-reverse ko siya. Okay? I-reverse ko siya, kaya may negative 1 ka dito. Tapos, ang delta RH naman for this reaction, the enthalpy of reaction for this reaction, okay, magta-times negative 1 tayo to reverse it. Again, ito naman na reaction, i-reverse ko. Okay? Next, for reaction 2, ang gagawin ko ay i-scale ko siya to 3. So, when we scale it to 3, ito yung mangyayari. So, magkakaroon ka ng 3 coefficient dito kay graphite, 3 coefficient kay O2, 3 coefficient kay CO2. And therefore, yung enthalpy of reaction for reaction 2, kailangan yung i-times 3 ang kanyang value. Okay? Lastly, for the third reaction, guys, ang gagawin ko is scale ko siya to 4. So, magkakaroon ka ng coefficient dito, 4H2 is 4, tapos 4. Okay? So, magiging 2. Ayan. Tapos, syempre, yung enthalpy of reaction, kailangan natin siyang i-times 4. So, using those scaling and reversing of the reaction, pwede ko na ma-obtain ang overall reaction below. O, tingnan ha. Assume, guys, na i-reverse ko yung first reaction. Sige, wait, clear ko lang. Pag ni-reverse ko kasi itong first reaction, guys, ang kanyang result ay 3CO2 plus 4H2O produces C3H8 plus 5O2. Okay? So let's see if pwede natin makuha ang overall reaction below. So we have C3H8 here, 3CO2 here. We know that we have 3CO2 here, right? Okay, using ko lang ulit. And then 4. Okay. We have 3CO2 on the product side. So cancel, cancel. Next, tingnan natin si water. May 4H2O ka sa reactant side and may 4H2O ka sa product side. Therefore, cancel, cancel. And then for 2O2, guys. Okay. So, teka, tingnan ko lang. Okay. So, for 2O2 naman, you have a total of 5O2 on the reactant side. Sa product side naman, you have a total of 5O2 as well sa inyong reaction 1. Therefore, maka-cancel mo ang O2 dito, O2 dito, and O2 na to. O ano lang yung natira, guys? It's 3C graphite plus 4H2 produces C3H8. Okay? And using the Hess's law, which we use here, okay, makuha natin yung overall reaction. And again, using Hess's law, we can calculate for the enthalpy of the reaction. So, isa-sum up nyo lang ito, ito, and ito. And then here, we will get the enthalpy of reaction, which is equal to negative 104 kilojoules per mole. Okay? Again, guys, yung ginawa ko dito is reverse yung reaction. So, ito na yun. Ito yung ginamit ko pang cancel with the reactions 2 and 3. Okay? Ayan, another sample problem, given the overall reaction below, calculate the enthalpy of formation for methane. So this is the formation of methane, and we have to get the delta FH. So guys, given tayo ng mga individual reactions na ito, so again, disregard nyo muna to. Okay? Given tayo ng tatlong reactions with their respective enthalpies of reaction, ang gagawin natin is to scale them in a way na makuha natin ang overall reaction below. So basically, ang goal is to get this overall reaction below. So for the first reaction, guys, wala akong gagawin dyan, hindi ko siya gagalawin. For the second reaction, I will scale it to 2. So magkakaroon ka ng coefficient na 2 dito, dito 2, so 1, and then dito 2. Okay? Tapos at the same time, i-multiply by 2 ko din ang enthalpy of reaction for reaction 2. Next for reaction 3, i-multiply ko siya by negative 1. So basically, ang gagawin ko kay reaction 3 is to reverse the reaction. So magiging ganito na siya. CO2 plus 2H2O, CH4 plus 2O2. Okay? Again, this is your new reaction since nireverse ko si reaction 3. Ang gagawin natin kay enthalpy of reaction for reaction 3 is to multiply it by negative 1. Okay? Now, let's see if makukuha na natin ang overall reaction na on the formation for methane. Okay? So here we can cancel CO2, right? Because it's on the reactant side and on the product side. We can also cancel, ano kaya guys? Tama, si 2H2O. So 2H2O is in the reactant side based on our reaction 3 and on the product side. So maka-cancel yan. Next, si CH4. So si CH4, guys, maka-cancel ba yan? Syempre, hindi, guys. Okay? Kasi nga, ang hinahanap natin dito is the formation for methane. Next, for O2, okay? So you have 1O2 plus 1O2 in your reactant side. Therefore, you have a total of 2O2 in your reactant side. And you have 2O2 in your product side. So maka-cancel nyo lang yan. Which gives us the overall reaction, C plus 2H2 forms CH4. Okay? I hope it's clear, guys. And then with that, ang gagawin nyo lang to get the enthalpy of formation for methane is to combine them all. I-add nyo lang ito sila lahat. Okay? The answer is, the enthalpy of formation for methane is negative 74.8 kilojoules per mole. And now let's proceed to enthalpies of physical changes. So, phase changes occur at constant pressure, meaning yung thermodynamic equations natin for heat apply to isobaric conditions. Kaya in phase transformation, guys, there are two types of heat na involved. First is sensible heat, which comes from temperature change, and latent heat, which comes from phase change. And so here, we see that upon the melting of ice to water and then to water vapor, okay, merong two types of heat na naproproduce. With that in mind, let's look at the heating curve of water as shown here. Okay? So let's say, guys, nag-start ang ice sa negative 20 degrees Celsius. Okay? Wala pang nangyayari sa kanya until i-heat siya. So when it is heated, it then reaches 0 degrees Celsius. Okay? So at this point, magkakaroon ka ng melting. Again, at this point, magkakaroon ka ng melting. Now, the melting process occurs at a constant temperature, diba? From here to here, right? So, melting process occurs at a constant temperature, which is the melting point, 0 degrees Celsius. Now, after mag-melt lahat ng ice, okay, tataas ulit ang temp. So, from here to here, pataas, until titigil ang pag-heat to 100 degrees Celsius, which is the normal boiling point of water. So, guys, when we say normal boiling point of water, it is the boiling point of water at 1 atmosphere. Okay? So, from here, guys, meron kang temperature change nangyayari. But once na umabot ka na sa 100 degrees Celsius, okay, the liquid will be converted to gas. Okay? So, meron kang phase change from liquid to gas at the boiling point. Okay? lastly, yung water vapor nyo, guys, when it is further heated, to eventually become a supercritical fluid. Okay? Yeah. So basically, guys, we have two types of heat. First is the latent heat. Ito yung tinatagong heat. Pag tinasabing tinatagong heat, ito yung heat na hindi due to temperature. It is due to a phase change. Okay? Meanwhile, when we say sensible heat, guys, okay, yun yung nakikita nating heat. Yun yung nararamdaman nating na init. Sana all. Charot. Okay, so guys, kailan nga ba tayo nakakaramdam ng init? So nakakaramdam tayo ng init, okay, if there is a change in temperature. So sensible heat, as said kanina, is heat accompanying temperature change. That's why the equation for sensible heat is Q is equal to delta H is equal to MCP delta T or NCP bar delta T. So pwede yung ganito. Well, the formula for latent heat is Q is equal to delta H is equal to a constant. Okay? So guys, marami mo nang pagdadaanan si water bago siya mag-melt or di kaya mag-vaporize. Okay? We have to take into account the latent heat and the sensible heat. Ma'am, how do you exactly solve for latent heat, sensible heat, and sensible heat? Okay? So guys, yung tandaan, yung mga latent heat and sensible heat na yan, these can be calculated using the constants of water in your table 10. Okay? So, for the enthalpy of phase change, where the process is fusion and vaporization, these are the corresponding enthalpy change values. So, for fusion, which is for melting, okay, the delta H is equal to 80 cal per gram. Now, for vaporization naman, it's 540 cal per gram. Okay? So, guys, ito yon sinasabi natin na latent heat. Ito. Because at phase changes, meron kang latent heat and ito ang respective delta H constants nila. Okay? So guys, baka nagtaka kayo, ginawa ko siyang in cal instead of in joules para mas madali siyang i-memorize. Okay? Pag in cal kasi, mas madaling i-memorize ang values ito. So for fusion, it's 80. For vaporization, it's 540. Okay? Then the units of enthalpy of phase change is cal per grams. Next, we have here constants, specifically the specific heat capacity of ice, liquid water, and steam. The respective delta H values is 0.5, 1, and 0.48. Oh guys, very easy to memorize lang ito, okay? So ito naman ang mga values gagamitin nyo in calculating for the sensible heat. Again, the specific heat capacity gagamitin natin to calculate for the sensible heat. Okay? The units of specific heat capacity is cal per gram times degrees Celsius. So guys, pwede pa rin na gamitin nyo ang cal per gram Kelvin for specific heat capacity. Okay? Okay lang yan. You can use any depending on the situation. In this situation, okay, ginamit ang degrees Celsius. Okay? Ayan, so let's proceed. Let's solve this sample problem. Calculate, okay, ayan. Calculate the total enthalpy involved in the conversion of 100 grams water from ice at 250 K to steam at 450 K. So S is sensible heat, L is latent heat. Oh guys, baka may gumawa sa inyo nito ha. Delta H is equal to 100 grams times Cp times delta T, which is 450 K minus 250 K. Di ba yun yung equation na MCP delta T? Oops. Which is equal to Q. Oops, mali yan, okay? Hindi to basta-basta, guys, na ganito lang, ka-straightforward, okay? Because maraming pagdadaanan ng ice before it melts to steam at 450 Kelvin, okay? Again, marami pang dagdadaanan si ice before it is converted to steam. So let's start. So to find the enthalpy change to sensible heat, delta H is equal to MCP delta T. Well, to get the enthalpy change due to latent heat, the delta H is equal to the constants. So solving, we have to summarize each step. Okay, so describe natin each step. Initially, you have ice at 250 K. Pag nag-increase yung temperature, guys, okay, the ice will reach a certain temperature, 273 Kelvin, which is equal to 0 degrees Celsius. That is the normal melting point, okay? And dahil dito, si ice at 273 Kelvin will undergo phase change. So ice at 273 Kelvin will become liquid at 273 Kelvin. Okay? So far, guys, from ice 250 to ice 273, meron kang na-produce na sensible heat, which is a heat due to temperature change because nag-increase ang temperature, right? Next, from the phase change from ice at 273 to liquid at 273, meron kang phase change. Kaya meron itong contributing na latent heat or heat due to phase change, which is, based on the table of the constants of water, it's 80 cal per grams. Step 3, si liquid at 273 Kelvin, pag nag-increase ang temperature until 373 Kelvin or 100 degrees Celsius, okay, it would have reached the normal boiling point. So at this point, guys, from the raising of the temperature from 273 Kelvin of liquid to the liquid 373 Kelvin, okay, meron kang temperature change, right? 273 to 373. That's why meron itong accompanying sensible heat. And you can calculate sensible heat through this equation. Delta H is equal to M Cp, which is 1 cal per gram Kelvin, times 373 minus 273. So this is the change in T. Okay? So pansin nyo guys, nilabas ko na agad si 100 grams dito. Okay? Kasi lahat naman itong mga steps na to, kailangan nila yung 100 grams mass. That's why nilabas ko na lang siya from the equation. Next, yung liquid at the normal boiling point, it will then undergo a phase change from liquid to steam at 373 Kelvin. And this results in latent heat. Again, the value for the latent heat is equal to, delta H is equal to 540 cals per gram. Lastly, pag in-increase mo pa further ang temperature ng steam mo to 450 Kelvin, okay, meron pa rin itong accompanying sensible heat. Okay, so in solving for the sensible heat, M, 100 grams, times Cp, which is 0.48 for steam, times 450, the final temp, minus 373, the temp for this. Okay. So through these steps, guys, we can finally calculate for the total enthalpy involved in the conversion of 100 grams water from ice at 250K to steam at 450K. So the answer is delta H is equal to 76,846 calories or 76.8 kilograms. Kilocalories, sorry. Again, 76.8 kilocalories. So kindly correct this on page P19. Again, the answer should be 76.8 kilocalories. O diba? Very easy lang. Basta memorize ninyo ang heating curve of water and of course, yung constants involved with it. Okay? And practice lang ng practice para sa problem na ito, guys. Okay? Next sample problem, a 100 grams ice cube at 0 degrees Celsius is dropped in a kilogram of water at 20 degrees Celsius. Assuming there is no heat transfer with the atmosphere, what is the final temperature of the water? So guys, meron tayong dalawang states na tingnan. So first, let's look at state 1. So state 1 ng ice, here the mass is equal to 100 grams and the temperature is equal to 0 degrees Celsius. Okay? Ang state sa kasama rin sa ating state 1 is yung water. Here we have water with a mass of 1 kilogram or 1,000 grams and its temperature is 20 degrees Celsius. Now, what if pinaghalo mo ang dalawang to? This will generate state 2. So, kay state 2, pinagmix na ang dalawang to. Okay? This is 1, this is 2. Here, makikita natin yung ice, magme-melt na siya sa glass of water. Okay? That's why we have a second state. Here, the total mass is equal to 1,100 grams. So, we just summed up ice and water. However, for the temperature, we have to get the final temperature of the water. Kasi, minix mo na ang ice and water together. Again, we have to find the final temperature. Okay? So how do we analyze this, guys? It is based on the law of conservation of energy, where Q ice plus Q water is equal to 0. Okay? Again, it is based on the law of conservation of energy. Okay? When we say Q ice, guys, okay, it is the energy needed to melt the ice. Plus, heat na ginain ni ice, heat gained by ice, that warmed from 0 degrees Celsius to the final temp TF. Again, Q ice is equal to the energy needed to melt the ice. So may accompanying phase change yan, plus the heat gained by melted ice which warmed from 0 degrees Celsius to TF, the temperature, okay? And then Q water naman accounts for the heat na lost by warm water, which cooled from 20 degrees Celsius to TF. Syempre guys, yung water nyo, since nag-add ka ng ice, magkukool ang water na yan because of the ice, which has a lower temperature. That's why you have heat lost when your water cools from 20 degrees Celsius to TF. So let's try to solve. So again, okay, this is the energy needed to melt the ice. Okay? So ito yung ating latent heat. And ito ang ating sensible heat. Meaning, ito yung heat na ginain ng melted ice when it warmed from 0 degrees Celsius, the initial temp, to the final temp, TF. Okay? Notice, guys, sa latent heat, I use the enthalpy constant, 80 cal per grams, right? For fusion. And then for the sensible heat, I use 1 cal per gram degree Celsius. Okay? Ayan. And then for Q water, basically that's just mass, which is 1,000 grams naman siya initially, times yung heat na nilose mo because nag-cool na nga yung water. So, it's times the CP, heat capacity, times TF minus 20. So, the initial temp is 20 degrees Celsius as shown here. And we have to get the final temp. And then equate it to 0. So, guys, all we have to do is use the shift solve function in order to find TF. So, let X is equal to TF. Now, try to solve, guys, on your own. Ano kaya makukuha nyo? Tama. The answer is the final temperature of water is 10.91 degrees Celsius. O baka may question kayo, ma'am, bakit hindi mo kinonvert to Kelvin? Guys, I don't have to convert it to Kelvin because magka-cancel out naman lahat ng degrees Celsius units mo. Okay? So, kunwari, ito, degrees Celsius to, magka-cancel out siya with this. Ito rin, with this. Okay? That's why hindi ko na binago yung units ng temperature. Okay? So, in the case of thermochemistry, in the case of phase changes, you don't have to change the units of the temperature as long as consistent. Okay? Yan. So in summary, these are the enthalpy changes associated with physical transformation. So again, we have enthalpy of fusion. So it is the enthalpy change when 1 mole of solid is transformed into a liquid. So ito yung nangyayari pag may melting. Okay? Enthalpy of fusion yun. Okay? So for example, when water, ice as water, becomes liquid water. Okay? Next, the enthalpy of vaporization, delta vap H, is the enthalpy change when 1 mole of liquid is converted into vapor at boiling point. So from liquid to water vapor. Lastly, for the enthalpy of sublimation, delta sub H, it is the enthalpy change when 1 mole of solid is converted into gas below melting point. So basically, the enthalpy of sublimation is just the sum of the enthalpy of fusion and the enthalpy of vaporization. So this occurs in sublimation where solid converts into gas. Okay? So tandaan guys, ang mga terms na to. Okay? Now let's proceed to enthalpies of chemical changes. So, recap lang natin, the standard enthalpy of formation, delta FH, is the enthalpy change when 1 mole of a compound is formed from its elements in their most stable states under standard conditions. So guys, pag sinabi natin reference states, okay, it is the most stable form of the elements at standard conditions. Okay? Ganun talaga, pag reference or free elemental states, okay, hindi natin sila kailangan i-form sa nature because they already exist in nature. That's why the heat involved to form them in nature, yung mga elemental states na yan, is just equal to 0. So for example, here, the standard enthalpy of formation for carbon graphite is equal to 0. Okay? Because it naturally exists. Okay? You don't have to have heat involved in order to form them in nature. That's why delta HF for graphite is equal to 0, and ganun din for oxygen. Okay? However, for the standard enthalpy of formation for carbon dioxide, it has a value. That is 393.5 kilojoules per mole carbon dioxide is released. Okay? Again, negative. Ang value ng delta H means energy is released. Okay? I hope it's clear, guys. Okay. Next. Again, the standard heat of reaction is the amount of heat absorbed or released when the reactants completely transform into products in standard conditions. So again, review lang to from earlier. Again, the standard heat of reaction is just the summation of the delta H of products minus the summation of the delta H of reactants. Okay? So for example, we have a hypothetical reaction A plus 2B which forms 3C plus 4D. Okay? Para makuha natin yung standard heat of reaction, products minus reactants. So, the coefficient here is 3. That's why 3 ang coefficient natin times the standard enthalpy of formation for letter C plus 4 times the standard enthalpy of formation for D minus reactants. So, sa reactants, you have A and B. So, for A, you don't have a coefficient. 1 yan. So, minus, okay, delta FHA. So, that's the standard enthalpy of formation for A. Minus 2 times the standard enthalpy of formation for B. Oh, ma'am, bakit minus yan? Guys, originally, ganito yan. Plus 2 delta FHB. Pero dinistribute ko na lang yung minus sign para madali niyong makita, okay? So this is how you calculate for the standard heat of reaction. Also, guys, I want you to take note of this. Pag sinabing delta RH naught, yung standard heat of reaction, yung units niya is in kilojoules per mole reaction. Tapos, yung 3 dito, yung coefficient nyo, ang kanyang units is 3 mole, for example, si C, letter C, yung substance nyo, over mole reaction. Again, yun yung interpretation ng mga ratios. 3 mole of carbon, mole of C, letter C, per mole reaction. Tapos, yung delta H, FC nyo na naman, ay ang units niya ay kilojoules per mole C. Diba? Kasi, para kay C lang naman ang delta FH na to. So, we can cancel this out and you can just easily get the units for the standard heat of reaction, which is kilojoules per mole reaction. Okay? Ayan. Let's proceed. Now, we also have what we call the standard enthalpy of combustion, delta CH naught, which measures the amount of heat when 1 mole of solid glucose is burned completely. Okay? So, our requirement natin dito, guys, is 1 fuel. Always, guys, na ang coefficient ng fuel is always 1. And then, combined with water forms carbon dioxide and water. Okay? So, the formula in getting the standard enthalpy of combustion is this. So, that's X, which is the coefficient of CO2, times the standard enthalpy of formation for CO2, plus Y, the coefficient Y, times the standard enthalpy of formation for water, minus the reactant, which is fuel. So that is the standard enthalpy of formation for fuel. Guys, hindi kasama si O2. Again, ang kanyang delta H is equal to 0 because this is in its elemental state. Okay? Again, this is equal to 0. Now, guys, may introduce ako sa inyo na special formula. Okay? It's a special formula for finding the standard enthalpy of reaction. If kunwari, lahat ng species sa reaction na yan are combustible. So you can just use the shortcut formula. Again, pwede nang ito gamitin if you're finding the standard enthalpy of reaction, tapos given kayo ng standard enthalpy of combustion values. So to get that, it's simply standard heat of reaction is equal to the summation of the standard enthalpy of combustion of the reactants minus the summation of the standard enthalpy of combustion for the product. So reactants minus products. Okay? So guys, what if ito, delta FH instead of delta CH? So syempre, dapat baliktad na. Dapat ang gagamitin nyo is delta RH is equal to summation of delta FH products minus summation of delta FH reactants. Okay? So again, applicable lang to if combustible ang species mo. Okay? So guys, this table summarizes the various enthalpies of chemical changes. So again, we discussed enthalpy of formation. Okay? And then we also discussed enthalpy of combustion. Okay? Guys, correction dito ha. The value of the standard enthalpy of combustion is negative 2808 kilojoules per mole reaction. Okay? And then for enthalpy of neutralization, that is also a type of enthalpy for chemical changes. Okay, here, enthalpy change occurs when 1 mole of water is formed in a reaction between an acid and an alkali. So you have an enthalpy of neutralization here. Okay? Next, we also have what we call enthalpy of dissolution here. Enthalpy change occurs when 1 mole of solute, kagaya ng NaCl, dissolves completely in a solvent such as water to form an infinitely dilute solution. So here we see that NaCl, okay, dissolved in water to completely dissociate. Okay? So guys, how do we interpret the enthalpy of combustion? Okay? Diba sabi dito, yung enthalpy of combustion natin is negative 2808 kilojoules per mole reaction. Ang meaning nito guys, 2808 kilojoules of heat is released if 1 mole of solid glucose is burned completely. Okay? What if guys, gusto nyo makuha yung enthalpy of combustion per mole of glucose? Ang gagawin nyo lang, ito, 288 kilojoules per mole reaction. Tapos, okay, tandaan nyo lang na per 1 mole reaction, ilan ang glucose? 1, diba? Kasi 1 naman ang coefficient dito for glucose. So the enthalpy of combustion per mole of glucose is equal to simply negative 2808 kilojoules per mole glucose. What if gusto nyo naman yung enthalpy of combustion per mole of CO2? Sige, let's try to solve that. So we have negative 2808 kilojoules per mole reaction. Tapos, gusto mo daw ng enthalpy of combustion per mole of CO2. So let's convert. Per 1 mole reaction, how many carbon dioxide do we have? It's 6, right? So 6 mole CO2. And with that, mag-iiba na ang value ni enthalpy of combustion. Okay? Because in terms of mole CO2 na yung gusto nyong mahanap. Okay? Now let's move on. So guys, again, for the value of the enthalpy of combustion for glucose here, kindly correct this on page P20. Okay? Ayan, so let's try to solve. The standard enthalpy of combustion of glucose is negative 2808 kilojoules per mole. How much heat is released if 10 moles of carbon dioxide involve from the combustion? So here we have the combustion reaction. And then let's analyze the given problem. Sabi dito guys, hinahanap ang heat release if 10 moles of carbon dioxide evolve from the combustion. Okay, so given ka ng 10 moles CO2. Okay, so ang gagawin natin, plug in 10 moles CO2 and then express it in terms of mole glucose. Because yung standard enthalpy of combustion of glucose is negative 2808 kilojoules per mole glucose. Okay, so again, so convert natin siya to mole glucose. So based on this reaction, guys, 1 mole of glucose is equivalent to 6 moles of carbon dioxide. Kaya makacancel siya. Tapos, ipa-plug in natin yung standard enthalpy of combustion of glucose para malaman natin yung heat release if 10 moles of carbon dioxide evolve from the combustion. Okay? So, multiplied by the standard enthalpy of combustion, negative 2808 kilojoules per 1 mole of glucose. So, cancel 1 mole of glucose, cancel, we get negative 4680 kilojoules. Thus, the heat released if 10 moles of carbon dioxide evolve from the combustion is equal to 4680 kilojoules. Okay? Now let's proceed to the variation of enthalpy change with temperature. So sabi ng Kirchhoff's law, the enthalpy change of a reaction varies with temperature due to the differences in heat capacity Cp between products and reactants. Okay? So we can say that both enthalpy and heat capacity are temperature dependent. So guys, basically, we can determine the heat of reaction at T2, at a final temperature T2, using this equation, where delta RH T2 is equal to the enthalpy of reaction with respect to the initial temperature T1 plus the integral of the change in Cp from T1 to T2. Okay? Oh, ma'am, saan galing yung change of Cp nito? Saan galing yung delta Cp nito? So you can solve it through this equation. Okay? So we can get delta Cp through calculating the summation of the Cp of products times their coefficients minus the summation of the Cp of the reactants times their respective coefficients. Okay? So again, ito yung formula to get the delta Cp. Tapos, kukunin yung integral niya from T1 to T2, then i-add niya with the delta RH T1 to get the delta RH T2. Okay? Again, the delta RH T2 is your heat of reaction, the final temperature T2. Okay? And in relation to this, you can also simply get the enthalpy, which is equal to the integral of Cp dt with the interval from T1 to T2 temperatures. Okay? So to easily understand that, kindly refer to the sample problem. Okay? Ayan. The enthalpy of formation of water vapor at 298 Kelvin is negative 241.82 kilojoules per mole. Estimate its value at 373 Kelvin given the following molar heat capacities in J per mole K. Water, hydrogen, and oxygen. So guys, given tayo ng initial temperature 298 K, right? That is T1. And we are given its enthalpy of formation, which is negative 241.82 kilojoules per mole. However, we have to estimate the value of the enthalpy of formation of water vapor if the temperature is now 373 Kelvin. So this is your T2. Tapos gagamitin yung mga Cp values ng water, hydrogen, and oxygen in order to get delta Cpp. Okay? So first, this is the reaction, guys. H2 plus 1/2 O2 forms water. So yung basic reaction of H2 and O2 to form water vapor. Okay? And then, all we have to do is get the heat of reaction at 373 Kelvin. So how do we get that? Heat of reaction at 298 K plus the change in Cp dt from 298 K to 373 K. So solving, ayan. So yung given na enthalpy of formation of water vapor at 298 K, yun yung ating delta RH 298 K, plus the integral of 33.58 times 1 minus 28.84 times 1 minus 29.37 times 1/2 dt. So this is based on the fact that Cp products minus Cp reactants. O, tingnan natin. Yung yung molar heat capacity ni water is equal to 33.58. It is the product. So 33.58 times 1, this refers to water, minus the reactant. So we have first reactant is hydrogen with a molar heat capacity of 28.84 times 1 because its coefficient is 1. So this is H2 molar heat capacity. And lastly, oxygen is also a reactant, right? And its molar heat capacity is 29.37 times 1/2 because your coefficient is 1/2. So this is O2 Cp. Tapos, gamitin nyo lang calculator nyo, guys, in order to solve for this because may integral function naman yung ating calculator. So solving, we get, ano na po you guys? Tama. Delta RH 373K is equal to negative 243 kilojoules per mole. Ayan. Okay, last example. What is the change in enthalpy of 1 mole of ideal gas if its temperature increased by 50 degrees Celsius from room temperature? The equation for Cp is given below. So in this case, guys, yung T1 nyo is room temperature, which is usually 298K, right? Or 25 degrees Celsius. Tapos nag-increase daw by 50 degrees Celsius. So that's just 25 degrees Celsius plus 50 degrees Celsius. Okay, which is equal to 75 degrees Celsius. And in order to get the change in enthalpy of 1 mole of ideal gas, binigyan tayo ng expression ng Cp. Panoorin nyo ha. To get the change in enthalpy, we simply use this equation because we are given this expression. So solving, delta H, change in enthalpy is equal to T2, T1 sa integral. So, of course, yung initial temp is 25. So, plus 273, kinonvert ko lang to Kelvin. Tapos sa T2 nyo, 25 plus 50 because the final temperature increased by 50 degrees Celsius plus 273 to convert the temperature to kelvins. And then I plugged in this expression. Okay? So, basically, guys, itong T na to, let it be X. Okay? When you plug it sa calculator. So, plug all of this in the calculator, we get delta H is equal to 1,342 joules. Okay? I hope that's clear, guys. Ayan, so patapos na tayo sa ating thermodynamics 1. Congratulations, guys. I know, sobrang hirap. Ang daming concepts na kailangan alahanin, ang daming need i-memorize. Pero tandaan, guys, as long as magpursige kayo na mag-memorize equations, mag-practice on how to solve these equations, kayang-kaya niyo ang FICAM, okay? And ang important talaga sa FICAM, guys, is the conceptual knowledge na alam nyo. Okay? Mahalaga na alam nyo yung conceptual reasoning behind calculations. Okay? So now, time for our pasalubong. Okay? The SERP. So, it confirms that the internal energy delta U of an isolated system is constant, but it may transform from one state to another state. What is that? First, law of thermodynamics. Next, it is a sign convention when work is being done by the system. It is negative. Next, in this process, heat is absorbed by the system from the surroundings. What is that? Endothermic. Next, it describes how the internal energy transforms as the system's volume expands or contracts at constant temperature. That is internal pressure. A state function that represents the total heat content of a system at constant pressure. Ano yan, guys? Tama, that's enthalpy. Oh, last Chloe cards, last pabaon for today. This equation shows the relation of Cp and Cv at ideal conditions. Ano yung equation na yan, guys? Cp minus Cv is equal to R. This phenomenon occurs through an adiabatic and isenthalpic expansion in a system with thermally insulated walls. O ano kaya to, guys? Adiabatic and isenthalpic expansion. Oh, look at your manual. Tama, that is the Joule-Thomson effect. Next, it measures the amount of heat involved in a combustion reaction. That's bomb calorimeter. The standard enthalpy of an overall reaction is the sum of the individual reactions into which the reactions might be subdivided. O ano kaya yan, guys? Hess's law. Lastly, the enthalpy change of a reaction varies with temperature due to differences in heat capacities between products and reactants. The answer is Kirchhoff's law. Yay! So, congrats, guys. Tapos na tayo sa part 1 ng ating thermodynamics crash course. I'm really proud of you guys that you've made it through this video, okay? So guys, please, if you have any questions at all regarding thermodynamics 1, please don't hesitate to message me. Ayan. So now you may answer physical chemistry practice test 2. So this is for 10 items that you can answer in 25 minutes. Guys, I highly suggest to you na sundan nyo yung time limit, okay? Lalo na sa physical chemistry para ma-practice nyo yung speed na dapat meron kayo. Dapat masanay kayo sa speed ng pagsagot ng physical chemistry questions, okay? Dapat hindi masyado tayo mabagal. Okay? Again, if you have any questions at all, feel free to message me. I will do my best to answer you as soon as I can. Okay? Okay. So this week, guys, we have finished Quantum Mechanics 1 crash course video, Quantum Mechanics 2 crash course, and Thermodynamics 1 crash course video. Okay, so our PT discussion for these 3 topics will be on July 13th. Next week, we will be discussing Thermodynamics 2, the gas